Assalamualaikum and hi all to my friend and my lecturer. My name is Muhammad Abqari bin Zulkifli with metric number 288492. Imagine you guys are in a jungle or even there is a disaster happening right now. One of the crucial things that we need to have as a human being is water. And of course, we can just simply get any water from kind of source thinking that it's drinkable. That's why we need something to predict what the quality. So me and my team group six have successfully make a project for this task, which is water quality prediction. To be exact, we use artificial intelligence to help us identify whether the water is actually drinkable or not. We use supervised learning for our project, so it's really simple on how to use this. We just need a few data set and voila, know that know that water is drinkable or not. For more info, I will pass it to my friend to continue with it.
I'm Secretary Doctor. My name is Foong Weng Yau. My metric number is 289851. Today, I'm here to present the basic concept behind the code. The basic concept behind this code is the supervised learning is applied to learn the dataset of water quality parameters, which already labeled with the exact value and portability, so the algorithm can learn it. Let me show you. This is the .csv, which means the dataset file. The range of values for the both portability is keep overlapping, and the input of random parameter values is not so logical since such water body may never exist. Thus, the portability output is depends on the certain combination of parameter values of the water bodies and not the range of the parameter values for the relatively. Next.
Okay, hello everyone. So my name is Ahmad Asyraaf bin Norazlan, metric number 284368. So I will explaining about the output of the coding. So first, we start to run the code. So we showing the GUI or the graphical user interface for the users. So first, we need to key in all the parameter values. So I will be explaining about the parameter values for the drinking waters. So as we know that pH value for the safe for drinking water is average 6.5 to 8.5, and the hardness is below 75 milligram per liter. And then for the solid is 500 ppm, chloramine is 4 milligrams per liter, and the sulfur is less than 500 milligram per liter, and the conductivity 200 to 800 nanosulfate per centimeter, and the organic carbon is 2 milligram per liter, and the THM is 100 nanogram, and the coliform is almost undetectable, so 100 milligram. So thus, after we key in the parameter values, we assume that this did not cause the burden in human body system and provide sufficient elements for human to carry out biological and daily activities. So I will pass to next person to explain about the not safe for the human consumption values.
Good day, doctor and everyone. I'm Thivya Sri with metric number 284594. So now I will continue with the second part of the output, which is water is not safe for human consumption. The suitability for the use of the water for drinking will be determined based on the WQI, which is Water Quality Index. According to the dataset, when the potability is 0, then the water is not safe for human consumption. So this is an example of water bodies which extract from river water at industrial areas. As you can see, there are excess amounts of total dissolved solids, hardness, which means calcium and magnesium. They may be produced by the chemical reaction that occurs in those industries. Those excess amount will harm human health. When we click the predict button after entering different values for the parameters, it shows water is not safe for human consumption. So that's all from me. Next, my friend will continue the presentation. Thank you.
Good morning, everyone. My name is Harshini Alages, matrix number 288, 286, and today I'll be showing you the graph for the tested water. So this graph shows us the probability density for the pH, and the skewness is 0.04. Next, this graph shows us about the probability density for the hardness, and the skewness is negative 0.04. Following, the probability density for this graph for solids is positive 0.62. Next, the probability density for chloramines is negative 0.01. The probability density for sulfate is negative 0.03. For this graph, it shows the probability density for the conductivity, which is positive 0.26. Next graph is probability density for organic carbon, and the skewness is positive 0.03. Following, the probability density for trihalomethanes is negative 0.09. Finally, the probability density for the turbidity is negative 0.01. I'll pass over the presentation to the next presenter. Thank you.
Assalamualaikum, my name is Fasihatul Amira Binti Jamaludin, number 328341. I will be showing you about box plot graph. This is a box plot graph for hardness, and the median is about 200. Next is the box plot graph for solid, and the median is about 20,000. This is a box plot graph for chloramines, and the median is about 7. This is a box plot graph for sulfate, and the median is about 300. This box plot graph for conductivity, and the median is about 400. This is a box plot graph for organic carbon, and the median is about 15. This is a box plot graph for trihalomethanes, and the median is about 17. And lastly is the box plot graph for turbidity, and the median is about 4. This is a heat made of confusion metric, and it indicates the performance for supervised learning. Thank you.